This topic is about sketching cubic and quartic functions. We need to be able to fully factorize a cubic and sketch its graph. We also need to be able to sketch a mixture of graphs and consider where each graph will overtake another. So when we're sketching cubics, we need to know that the functions are of the form y is equal to ax cubed plus bx squared plus cx plus d, where a is not allowed to be 0, because if a is equal to 0, then it reduces down to a quadratic, which is no longer a cubic. So a has to be a non-zero number. Now we have two cases. So we have the case where a is greater than 0, which means our cubic graph is a positive cubic graph, which means it will start at quadrant 3 and then end up in quadrant 1. So if I label the quadrants, so this is quadrant 1 normally, quadrant 2, quadrant 3, and quadrant 4, then it starts from 3 and goes to 1. Okay, and you can see the x-intercept, there's 3 x-intercepts there and 1 y-intercept. Now, obviously a could be less than 0, and in that situation, then your cubic graph will start off in quadrant 2 and end up at quadrant 4. So this is 1, 2, 3, and 4. So in a greater than 0, it goes from 3 to 1. But in a less than 0, you go from 2 to 1. 2 to 4, sorry. 2 to 4. Okay, the other things to note is in the first category, as x tends to negative infinity, so as x gets closer and closer to negative infinity, y is also going to negative infinity. And as x gets closer and closer to positive infinity, so as x is getting bigger and bigger, y is also getting closer and closer to positive infinity. Okay, here, as x tends to negative infinity, y tends to positive infinity. So you can see as x is getting more and more negative, y is getting more and more positive. And as x tends to positive infinity, then as x is getting more and more bigger, y is getting more and more negative. So y tends to negative infinity. Okay, the thing to watch out is there are special cases. So they don't always look like this. So there are special cases. So one of the special cases is when you have a triple root. So for example, when there's a triple root, it'll only have one x-intercept. So this point here is a triple root. And it sort of does it like a little twist at that point, and it goes across. Yeah. So this happens when there is one root and it's a triple root. Okay, and also a different case is when you have a double root. So when you have a double root, so the first root might be a single root, so it goes through, but the second root might be a double root, where it bounces off. So this one is a double root here. So it doesn't cross over to the other side of the x-axis, it just bounces off the x-axis. So that's a double root. And here you can see there's, in the first example, there's 3 single roots. That's why it always crosses over to the other side. 3 single roots here, so it always crosses over to the other side. In a triple root, it does a twist and then it crosses over. In a double root, it doesn't cross over, it just bounces off and goes back to the same side. Okay, so just a thing to remember that the x-intercepts, there might be 1, 2, or 3 x-intercepts. Okay, let's look at a few examples of sketching cubics now. Okay, A. So y is equal to 2x minus 3 times x minus 2 times x plus 1. Then straight away, the x-intercepts are when 2x minus 3 equals 0, when x minus 2 equals 0, and when x plus 1 equals 0, which means x must be equal to 3 over 2, x must be equal to 2, and x must be equal to negative 1. the y-intercept is the constant that you get at the end. So what you do is you multiply the last term in each bracket. So I get -3 times -2 times 1, which is 6, which implies the y-intercept is at y is equal to 6. Okay, if I multiply the first terms in each bracket, then I get 2x times x is 2x to the power of 3, which is a positive cubic, because it's positive 2x cubed, which implies the graph should be a positive cubic graph, so it should look like this. Okay, so if I were to sketch it now, let's sketch it on this side. So I've got x equals -1, so -1 is a x-intercept, x equals 2, so 2 is here, and x equals 3 over 2, so 3 over 2 here. Y is equal to 6 is a y-intercept, and it's a positive cubic graph, so that means it starts off at 3 and ends up at 1. Okay, so I can clearly see my graph will look something like this. Okay, and it's going endlessly in both directions. So that would be it. Now, don't worry about the minimum point and the maximum point. They aren't important at this point, okay? So it doesn't matter as long as you have the x-intercepts and the y-intercepts correct. Okay, I will just relabel this as -1 there. So you can see clearly that's -1. Okay, let's try the next example. So b, which is equal to y, is equal to 2x cubed minus 10x squared plus 8x. If I factorize the 2x out in the bracket, I get x squared minus 5x plus 4, which is a quadratic. And if I factorize this quadratic, I get x minus 4 and x minus 1. So after I've factorized it fully, now I know what my x-intercepts are. So my x-intercepts are x equals 0, x equals 4, and x equals 1. Now the y-intercept, when you expand this, in the expanded form, you know there's no constant. So y is equal to 0 is the y-intercept, because there is no constant here. There's no constant. Okay. And I've got y is equal to 2x cubed. Because it's 2x cubed, it implies it's a positive cubic, which implies it goes from 3 to 1. So it's going to be this way up. Okay, so if I were to sketch it, okay, so x-intercepts are x equals 0, x equals 1, and x equals 4. Y-intercept is 0, it's a positive cubic, so it starts off at 3, ends up at 1. So it's going to look like so. Okay, the last one, C. Y is equal to negative x plus 2 times x minus 1 squared. Now the x-intercept is at x equals negative 2. X is equal to negative 2 and x equal to 1. But because it's x minus 1 squared, that means this is a double root, because you've got x minus 1 times x minus 1. So x equals 1 is a double root. Okay. Now the y-intercept will be negative, because there's a negative at the beginning, times 2 times negative 1 from the first x minus 1 times negative 1 from the second x minus 1, which gives you negative 2, which implies the y-intercept happens at y is equal to negative 2. And if you multiply out the brackets, you get negative x times x times x from all three brackets, which gives you negative x cubed, which implies it's a negative cubic graph, which implies it's going to start off at quadrant 2, end up at quadrant 4. So if I were to do a rough sketch, x equals negative 2 is a single root, x equals 1 is a double root, so it's going to bounce off that part. Y is equal to negative 2 is a y-intercept. Okay, it's going to start off at quadrant 2. So start off at quadrant 2, end up at quadrant 4. It's going to bounce off this one because it's a double root at 1. So something like this going off. Okay, next question. On the same axis, sketch the curves given by y equals x squared minus 1 times x minus 2 and y equals 14x plus 2, and label the points of intersection with the coordinate axis for each. Then use your sketch to find the point of intersection between the two equations. Okay, so the first one, let's try this one first. So y is equal to x squared minus 1 times x minus 2, which is a cubic. If I factorize x squared minus 1, I get x minus 1 times x plus 1 times x minus 2, which means the x-intercepts are x equals 1, x equals negative 1, and x is equal to 2. The y-intercept is negative 1 times positive 1 times negative 2, which gives me positive 2, which means y is equal to 2 is my y-intercept. I get x cubed from this, which implies it's a positive cubic graph. So it's going to look like start off at quadrant 3, end up at 1. Okay, if I do a rough sketch of this one. Minus 1, 1, and 2. Y-intercept is at 2. Okay, so that's my cubic graph. Let's use a different color for the linear graph. Let's use this one. Okay, so you've got y is equal to 14x plus 2, which is a linear graph. Okay, so linear graph. X-intercept is when 14x plus 2 is equal to 0, which implies x is equal to minus 2 over 14, which is equal to minus a seventh. And the y-intercept is at 2. Y is equal to 2. So here is the y-intercept, which is at 2. And it's going to go 3 minus 1 over 7. Straight line graph. Then go like this. Now what we do know is eventually, because the cubic graph is getting bigger quicker, or smaller quicker, depending on which side you look at it, it's going to overtake it. Okay, so there will be a point of intersection here, and in a similar way it will overtake on the other side as well. So if I extend this line and I extend the linear line, there will come a point where the cubic is above the linear line. So there will be another point of intersection here. So there will be 3 points of intersection. So let's solve it algebraically and see if we do get these 3 points of intersection. So to solve it algebraically, we need to equate the two equations. So we've got x squared minus 1 times x minus 2 must be equal to 14x plus 2. So if I expand this side, I get, on the left-hand side, I get x cubed minus 2x squared minus x plus 2 must be equal to 14x plus 2. There's plus 2 on both sides, so I can omit it. X cubed minus 2x squared. If I take the 14x to the other side, I get minus 15x is equal to 0. If I factorize it, the x out, I get x squared minus 2x minus 15 is equal to 0. If I factorize the quadratic in the bracket, I get x minus 5 times x plus 3 is equal to 0, which implies I get roots as x equals 0, x equals 5, and x equals negative 3. Okay, if I substitute that into y is equal to 14x plus 12, I get y is equal to 14 times 0 plus 2, which means y is equal to 2. So x equals 0, y is equal to 2, which is this one, this point here, 0, 2, which makes sense. Y is equal to 14 times 5 plus 2, which means y is equal to 72. So 572 will be that one. So this one is 0, 2. This one is 572. And the last point will be 14 times negative 3 plus 2, which is negative 42 plus 2, which is y is equal to negative 40. So this one will be, the last point here will be negative 3, negative 40. Okay, have I labelled everything that I needed to? All the points of intersection, 1, 2, and minus 1 and 2. That's fine. So all the x-intercepts are labelled, all the y-intercepts are labelled, all the points of intersections are labelled as well. Okay. Next question. Okay, we've got a cubic graph, which is this one. Y is equal to x plus 1 cubed. Okay, now what I do know is x-intercept is x equals negative 1 is triple root, okay? Because x equals negative 1 is a root 3 times. It's a triple root. Y-intercept will be 1 times 1 times 1, which is equal to 1, which implies y equals 1. Okay, again, because you're getting x times x, which is x cubed, it's a positive cubic graph. So it's going to start off at 3, end up at 1. Okay, the second graph, which I'll do in a lighter blue, is a quadratic graph. So y is equal to 3x times x plus 1. So the x-intercept is x equals 0 and x equals negative 1. the y-intercept, if you expand, y is equal to 3x times x plus 1. You don't get a constant term. So y is equal to 0 is your y-intercept. And because you've got 3x times x is 3x squared, it's a positive quadratic. So it'll be this way around. Okay, so if I were to sketch it out, both the graphs. Okay, the first one is, so the cubic graph had x equals -1 as a triple root and y equals 1 as a y-intercept. Okay, so that means it's going to do a twist here and then it's going to go up. And the quadratic graph goes through -1 and 0. Okay, the y-intercept is also 0. It's a positive quadratic graph. So it looks like so. Now what we notice is because the quadratic graph increases at a slower rate than the cubic graph, it won't intersect on the right hand side. So the cubic will always be above the quadratic. Okay, so there seems to be only one point of intersection, which is -1, 0. So let's solve it algebraically and see if we do get that solution as well. So if I solve it algebraically by equating it, I get x plus 1 cubed is equal to 3x times x plus 1. If I expand this, I get x plus 1 times x squared plus 2x plus 1 when I expand two of the brackets, times 3x is equal to 3x squared plus 3x. Okay, if I expand this one, I get x cubed plus 2x squared plus x squared plus 2x plus 1 is equal to 3x squared plus 3x. If I collect the like terms on the left hand side, I get x cubed plus 3x squared plus 3x plus 1 is equal to 3x squared plus 3x. I can see I've got these in common on both sides. So I end up getting x cubed plus 1 is equal to 0, which means x cubed is equal to -1, which means x is equal to the cube root of -1, which is -1. If I substitute back into any of the equations, I get y is equal to -1 plus 1 cubed, which means y is equal to 0. So the point of intersection is only -1, 0. So -1, 0 is the only point of intersection. -1, 0 is only point of intersection, which makes sense with our diagram. Okay, one more example. So on the same axis, sketch the curve given by y equals x plus 1 cubed. So we've done this one already from the previous one. So let's do it again anyway. So y is equal to x plus 1 cubed. So x-intercept is equal to x equals -1, which is a triple root again. Y-intercept is equal to 1 times 1 times 1, which implies y is equal to 1. And when you multiply it out, you get x times x, which is x cubed, which implies it's a positive cubic, which implies it goes from 3 to 1, quadrant 3 to 1. Okay, the second one, so that was the first, which was a cubic graph. The second equation is a quadratic. So y is equal to x plus 4 times x plus 0.25, which is the same thing as x plus a quarter. So that means my x-intercept for this one is equal to x equals negative 4 and x equals negative a quarter. Y-intercept is equal to 4 times a quarter, which is equal to 1, which implies y equals 1 is a y-intercept. And because x times x is equal to x squared, it implies it's a positive quadratic, which is this way. So when we sketch these two graphs, okay, the cubic goes through, has a triple root at -1 and a y-intercept at 1. So it looks something like so. And then the cubic graph goes through -4, minus a quarter. It's a positive cubic graph, so there is an intersection here. Okay. It goes through y equals 1. Now for a part of the graph it is above the cubic graph, but then eventually the cubic graph will take over. Now the reason behind this is because between 0 to 1, when x equals 0 to 1, x squared is bigger than x cubed. But as soon as x is greater than 1, then x cubed will start getting bigger than x squared. So that's the reason behind it. So we think we're going to get 3 intersections when we solve this equation. So let's do that. Okay, so let's solve it by equating it. So I've got x plus 4 times x plus a quarter is equal to x plus 1 cubed. When I expand this, I get x squared plus 4x plus a quarter x plus 1 is equal to x plus 1 times x squared plus 2x plus 1. If I collect these up, I get x squared plus 17 over 4x plus 1. And if I expand this side, I get x cubed plus 2x squared plus x squared plus 2x plus 1, which means I get x squared plus 17 over 4x plus 1 is equal to x cubed plus 3x squared plus 3x plus 1. So I can cancel out this and this, and then we take everything to the right hand side. So I get x cubed plus 3x squared take away x squared gives me 2x squared. 3x take away 17 over 4x is the same thing as 12 over 4x take away 17 over 4x, which gives me minus 5 over 4x is equal to 0. If I factorize it out, or if I multiply everything by 4, let me just multiply everything by 4. So I get 4x cubed plus 8x squared take away 5 equals 0. Now factorize out the x, I get 4x squared plus 8x minus 5 equals 0. Now this is easier to factorize. So if I factorize it and out into 2x and 2x, then I know I need to put a positive 5 here and negative 1 here, which means I've got the solution. X equals 0, x equals a half, and x equals -5/2. Okay, if I substitute into one of these equations, let's do the cubic one, then I get y is equal to 0 plus 1 cubed, which is 0 plus 1 cubed, which is 1, yep. So that's my first solution, which makes sense because that's 0, 1, that first intersection there. If I do the next one, if I do half plus 1 cubed, I get 3/2 cubed, which is 27/8. Half 27/8 must be that one. And this is a -5/2. So it's -5/2 plus 1 cubed is -3/2 cubed, which is equal to y is equal to -27/8. So that must be that one, which is -5/2, -27/8. And those are my 3 points of intersections. The next problem. Okay, the graph of y is equal to x cubed plus bx squared plus cx plus d is shown opposite, where b, c, d are real constants. Find the values of b, c, d. Now we know the x-intercepts are x equals -3, x equals -2, and x equals 1, which implies that y must be equal to x plus 3 times x plus 2 times x minus 1, because the roots are obviously x equals 1, then x minus 1 must be a factor. Now the key thing here is it was y is equal to x cubed. Yeah, so we know when we multiply, there's no constant in the front. It's because when we multiply x times x times x, we're going to get x cubed. Okay, now we need to expand this. Y must be equal to x plus 3. If I expand the last two brackets, I get x squared, 2x take away x gives me plus x. And then 2 times -1 gives me -2. If I expand this now, I get x cubed plus x squared minus 2x plus 3x squared plus 3x minus 6. And if I collect like terms, I get x squared cubed plus 4x squared plus x take away 6. And this implies that we do have b is the coefficient of x squared, which is 4. C is the coefficient of x, which is 1. And d is the constant at the end, which is -6. Okay, so that would be my solution for part A. For part B, write down the coordinates of the point where the curve crosses the y-axis. Well, it's labelled there already, but if I wanted to figure it out from here, I've got my constant at the end, tells me my y-intercept. So it'll be 0, -6, because the constant is -6. Okay, next question. The graph of y equals ax cubed plus bx squared plus cx plus d is shown opposite, where a, b, c, d are real constants. Okay, the key thing here is a is not 1. Okay, so be very careful with that. Find the values of a, b, c, d. Okay, first of all, we know the x-intercepts are x equals -1, x equals 2, and x equals 3, which implies x plus 1, x plus 2, x minus 2, sorry, x minus 2, and x minus 3 are factors of y. So y will be equal to x plus 1 times x minus 2 times x minus 3, and a scalar multiple of that. So we don't know what this number is at the front here. We can't assume it's 1 because a is not 1 there. The little a is not 1. So we know it's of this form. Okay, but we also know that the y-intercept is 0, 2, which implies that if I substitute 0, 2 into this, I'm going to get my value of a. So 2 is equal to a times 0 plus 1 times 0 minus 2 times 0 minus 3. So 2 is equal to a times 1 times minus 2 times minus 3, which is 6. So a must be equal to 2 over 6, which implies a is equal to a third. Okay, so y is equal to a third times x plus 1 times x minus 2 times x minus 3. If I expand this out, y is a third times x plus 1. If I expand the last two terms out, I get x squared minus 5x plus 6. If I expand x plus 1 times x squared minus 5x plus 6, I end up getting x cubed minus 5x squared plus 6x plus x squared minus 5x plus 6. Y is equal to a third times x cubed minus 4x squared plus x plus 6, which means y is equal to a third x cubed minus 4 over 3x squared plus a third x plus 6 over 3, which is 2, which implies a is equal to a third, b is equal to minus 4 over 3, c is equal to a third, and d is equal to 2. Okay, the next skill that you need to know is how to sketch quartics. Okay, so quartics are of the form y is equal to ax to the power of 4 plus bx cubed plus cx squared plus dx plus e. So you've got one more term than the last one, which is the cubic. And a is not allowed to be 0, or else it will just be a cubic. Okay, now again, there are two cases. When a is greater than 0, okay, now it's sort of like a W shape. So you end up with something that looks like so. So it goes from quadrant 2 to quadrant 1. And we say as x tends to negative infinity, so and when x is getting more and more negative infinity, y is going to positive infinity because it's getting more and more positive. And as x tends to positive infinity, so as it's getting more and more positive, y is also getting more and more positive. Y tends to infinity. So just remember it goes from 2 to 1. The other case is when a is less than 0. Okay, you have the opposite case. Okay, and it starts from quadrant 3 and ends up at 4. As x tends to negative infinity, y tends to, so as x is getting more and more negative, y is getting also more and more negative. So negative infinity. As x tends to positive infinity, y, let's see what's happening to y. So it's getting more and more positive. X is getting more and more positive. Y is also getting more and more negative. Okay, so we say it goes from 3 to 4. Okay, there are special cases, so it doesn't always. So if you look at the two examples I've given you, you'll see there's 1, 2, 3, 4 x-intercepts. Again, in this one, there's 4 roots. Okay, sometimes your quadratic may have, your quartic can have 0, 1, 2, 3, or 4 x-intercepts. So I've given you obviously general cases when there are 4 x-intercepts. So if there is 3 x-intercepts, it means there's a double root somewhere. So if I were to sketch it out, Okay, so there might be one single root, and then there's a double root. So you can see there's 1, 2, 3. This one's a double root. So it can look like this as well. So this is when it's got 3 roots, yeah? Or it might be the case that you have something like this where there's 2 double roots. So there's a double root here, and there's a double root also there. So there's 2 roots in this one. Or it might be floating above there. So no roots. No roots. So there are more than one special case. Okay, you can also have the case where there's only one double root. So it only bounces off once and then nothing. So there's so many different special cases. Just remember, they don't always necessarily have to have 4 x-intercepts. Okay, let's do an example. So sketch the following showing the points where the graph meets the y-axis. Or maybe it's the coordinate axis. So first of all, we have the x-intercept as usual. So we've got x equals 0. X equals 2 is a double root. And x equals -2 is a single root. A y-intercept is, if I expand this bracket, I get no constant term, so y is equal to 0. And if I expand it, I get x times x times x times x, which is x to the power 4, which is a positive quartic, which implies it's going to look this way. So starting at quadrant 2, end up in 1. Okay, so if I were to sketch this roughly, okay, it goes through 0, it goes through -2, and it goes through 2, but it's a double root there. And y equals 0 is the y-intercept, okay, which means start off at quadrant 2, go through -2, goes through 0. Okay, at 2 it's a double root, so it's going to bounce off it. So remember, if it's a double root, it doesn't cross over to the other side of that x-axis, it just bounces off it. So that's a double root, and that would be it. Okay, sketch the following showing the points where the graph meets the coordinate axis. Okay, again, x-intercept is x equals 1 is a triple root, and x equals 3 is a single root. Now, a triple root, remember, it does a twist thing, okay? So we'll remember it's a point of inflection, it does a twist thing. We'll look at that when we draw it out. Y-intercept is -1 times -1 times -1 times 3. So multiply all the constants together, I end up getting -3, which implies y is equal to -3 is your y-intercept. When I expand my x's, I get x times x times x times -x, which is -x to the power 4, which means it's a negative quartic, which implies it's going to start off at quadrant 3, end up at quadrant 4. Okay, so if I were to sketch this, okay, x equals 1 is a triple root, so it's going to do a twisty thing there. X equals 3 is a single root, so it's just going to go through it. Y is equal to -3 is a y-intercept, so it's going to go through y equals -3. At 1, because it's a triple root, it's going to do a twisty thing, so it's going to like a cubic graph, like a twist. Okay, and then it's going to, because 3 is a single root, it's going to come through to the other side. So that's how it would look. One problem solving question before I finish. The graph of y is equal to x to the power 4. So here a is 1. So you don't have to worry about a scalar multiple. Plus bx cubed plus cx squared plus dx plus e is shown opposite, where b, c, d, e are real constants. Find the coordinates of P. Okay. So because we know x-intercepts are x equals -2, and they're all single. There's 4 x-intercepts, so we know it only goes through it. It's a single root. X equals -2, x equals -1, x equals 2, and x equals 3. It means y must be equal to x plus 2 times x plus 1 times x minus 2 times x minus 3. So if I find the y-intercept, I'm going to do 2 times 1 times -2 times -3, which gives me 12, which implies y equals 12 is my y-intercept, which means my point P must be equal to 0, 12. For part B, we're trying to find the values of little b, c, d, and e. So I already know that my equation is of this form. The non-expanded form is this. So all I need to do is expand it to get my answer. So let's expand the first two brackets. I get x squared plus 3x plus 2 times x minus 2 times x minus 3. Y must be equal to, if I expand the first two brackets again, I get x cubed plus 3x squared plus 2x minus 2x squared minus 6x minus 4 times x minus 3. If I simplify the first bracket, I get x cubed plus x squared minus 4x minus 4 times x minus 3. If I expand it again, I get y is equal to x to the power of 4 plus x cubed minus 4x squared minus 4x minus 3x cubed minus 3x squared plus 12x plus 12. If I simplify this, I get x to the power of 4 plus minus 2x cubed, minus 4x squared minus 3x squared gives you minus 7x squared, minus 4x plus 12x is plus 8x, and then plus 12. And this implies that b is equal to -2, c is equal to -7, d is equal to 8, and e is equal to 12.